सर फोन पे
रिकॉर्डिंग रोक दो। ठीक है आपके घर अब आएगा कोरियर वीडियोस बाय विजेता ये सब मंथली मैगजीन ऐसे ठीक है वो करती है कैसे करो एक डायरी दे रहा है डायरी रखना है सबको अपना काम डेली उसमें लिखना है क्या हुआ है कैसे हुआ है ठीक है तो भूलोगे नहीं मेरी बात करो
हाँ म्यूट है की बात है शुरू हो रहा है has not started सर अभी कर रहे हो चलो हाँ कर लेंगे Good morning everyone. I hope we have enjoyed the previous session on cryptarithmetic and you have learned something new from there. Okay. In today's session we are going to deal with another niche topic on percentages. Okay. Especially such type of problems are called election based problems. Out of all the percentage problems that students face, they have a fear psychosis, especially on election based problems. So we are going to see in the first few minutes the basics regarding election based problems, and then in a series of escalating difficulty we are going to solve some problems too. Okay. So since election based problems is one niche of percentage based problems, different percentage based problems could be, one could be on matrix based, where they give you 3 or 4 types of 4 divisions in a certain problem itself and ask you 50% of this is this, 50% of this is this. Okay. So one niche is matrix based problems, and in the same percent, out of the universe of percentage problems, okay, one is matrix based and another important is election based. Okay. So these borrow the principles from percentages only. All the basic concepts of percentages that you need to master remain the same, but what changes is our approach and our application. Okay, so while seeing this topic today, we'll start with basic itself, although it might not be rational on my part to start with the whole of percentages. I'll just start with few basic points that you need to master in order to solve any problem on percentages. One is percentage to fraction conversion. Percentage to fraction conversion. And the second important point that you need to master in for doing election based problems or any application based problems, especially in percentages, is ratio or multiplication factor approach. I see many people just if they say any percentage problem, the common habit is start with some 100 or 100x. It is not exaggeration if I say that most of the times, except where the problems are basic, you can get away with assuming 100 and 100x. But in any complex problems, if there is a twist, you are sure shot guaranteed to get stuck up in the problem. Okay, so my first advice to all the students is be fluid in your approach. Do not stick to a certain approach. Any percentage problem, I will do the same way. That is a wrong way to approach problem. You should change your approach based upon the question being asked. Okay. So in today's basics, we will see these two. Okay. I hope this covers everything that is sufficient to do election based problems. And it is not convenient for me to start with all the percentage basics, and because in percentages you have successive percentages and then ways to deal with successive percentages, formula based and all. Okay, we don't need all that, but we'll see basics required to solve election problems. Which is percent to fraction conversion and ratio or multiplication factor. These two especially are tools to solve the problem. Okay, it is not that you can only do through ratio or multiplication factor. It can be done through assuming initial values as 100 and 100x, but it is always advisable to start with to do the problem in ratio or multiplication factor way. Okay, now let's start with the basics. What is the percentage? A percentage is, it is embedded in the name itself, percentage. Okay, percentage, that means per 100. So whatever you are measuring, suppose if I give you a simple example, what percentage is 25 out of 50? What percentage is 25 out of 50? Okay, what does this question mean? Okay. If it is 25 on a base of 50, if it is 25 on a base of 50, your percentage is nothing but the value on a base of 100. Okay, so 50 is multiplied twice, so 25 being multiplied twice will give you 50. So 25 out of 50 is also 50%. Okay, 50%. So if you see composition of a percentage, it is always there is some reference and there is some actual value. Okay, there is some actual value and there is reference. See this and tell me, what does this represent or what does this resemble? Doesn't it resemble a fraction? There is some numerator x, there is some numerator x, there is some denominator y. Doesn't this look like a fraction? Okay, so your percentage is nothing but another form of fraction. Okay, so percentage to fraction conversion solves many of the problems that are inherent with the initial 100 method. Initial 100 method is when you see a problem, you just take the initial value as 100 and derive based upon the information given. Okay. Many of the pitfalls of initial 100 based problems can be avoided if you are good with percentage and fraction. Okay. I am not going to go through all the percentages, but some basic percentages which are required to solve the problems, we will see a few of them. Okay. First, 1 by 1, this is nothing but its equivalent. What is its equivalent percentage? 100%. Next, fraction of 1 by 2, it is 50%. Okay. So, what do you do to convert fraction to percentage? It is nothing but just multiply it by 100. In the same sense, 1 by 3 is 33.33%. Next, 1 by 4, 25%. 1 by 5 is 20%. Next, 1 by 6 is 16.66%. 1 by 6 is 16.66%. 1 by 7 is 14.28%. Okay. Most people are comfortable until here. Okay. They get into difficulties once this keeps on progressing. So, I want to give you some memory tools. You see, 1 by 6, the equivalent percentage is just combine this one and this 6. Okay, it is 16.66%. You can use this as a memory peg. Okay. Next, 1 by 7, you see its equivalent percentage, 7 2s are 14 and 14 2s are 28. Okay. So, 1 by 7 is 14.28%. I hope this is clear. Next, 1 by 8. 1 by 8 is 12.5%. 1 by 8 is 12.5% and 1 by 9. Okay. One easy way to remember 9 is 9 forms a complementary pair. 9 forms a complementary pair with 11. Okay. Whenever you see 9 in the denominator, 11 appears in the fraction or multiples of 11 appear in the fraction, and whenever you see 11 in the denominator, okay, you will see multiples of 9 in the fraction. How? We will just see. 1 by 9 is 11.11%. Okay. 9 in the denominator, multiples of 11. 11 into 11 ones are 11. Next, 1 by 10, it is simple, 10%. Next, I hope until here it is clear. Okay. Now, let us see few more. 1 by 11. Remember the pairing between 9 and 11? 9 in the denominator, 11 comes in the fractional part, and 11 in the denominator, 9 comes in the fractional part. It is 9.09. Next, 1 by 12. Okay. 1 by 12 is 8.33%. 1 by 12 is 8.33%. Another important way you can remember this is, what is 1 by 12? Can I write 1 by 6? Divided by 2. Okay. 1 by 6 divided by 2 is nothing but 1 by 12, or 1 by 6 into 2 is 1 by 12. Okay. So, what is 1 by 6? 1 by 6 is 16.66. I have already given you a memory pick for this. 1 by 6, 1, 6, 16.66. Okay. So, 1 by 6 by 2, it is nothing but 8.33%. 1 1 by 12 is 8.33%. Next, 1 by 13, 7.69%. It is important to remember this. Why? 1. On the occasion that 13 is a prime number, okay, all denominators which have a prime number 7, 13, 5 we already know, 2 already know, those are simple. Okay. So prime numbers, these are important. So 1 by 13 is 7.69. 1 by 14 is 7.14%. Next, 1 by 15 is 6.66%, or you can also see this as, what is 1 by 5? 1 by 5, can I write 1 by 15 as 1 by 5 divided by 3? So 1 by 5 is 20, 20% divided by 3, okay, 6.66%. Okay. So 1 by 15 is 6.66%. So once you are comfortable with percentage to fraction conversion, ratio or multiplication factor approach, or your base 100 method, okay, these are some of the common tools. These are some of the common tools used to solve percentage problems. Okay. So let us discuss multiplication factor approach here. I hope initial as 100 is self-explanatory. So what will you do in a multiplication factor approach? Suppose, for example, multiplication factor has been defined as final value by initial value. For example, if something increases by 50%, if something increases by 50%, what is the normal way you do? You assume the value as 100 and the new value is 150. Okay. You assume old value be 100, it is increasing 50%, that means 50 units on 100 units. So the new value will be 100 plus the increased units, which becomes 150. Okay. So doing the same example here, okay, an increase of 50% can be represented, okay, in this fashion. Now we have defined multiplication factor as final value, which is 150, by initial value, which is 100. So if you take out the ratio, it is 3 by 2. I hope this is clear for people who are hearing multiplication factor for the first time. We need not go in this roundabout way. Whenever you see percentages, you can directly find out the multiplication factor. How? First, step 1. Step 1 of what? Step 1 of converting your percentage to multiplication factor directly. We will see this through a few good number of examples. Okay. Suppose there is an increase of 50%. Suppose there is an increase of 50%. Step 1 is write its equivalent fractional form. This is in the percentage form. 50% is 50%. Write its equivalent fraction form. 50% is, what is its equivalent fraction? 1 by 2. Okay. So to find out multiplication factor directly, it is 1 by 2. Now your multiplication factor is 1 plus of percentage equivalent fraction. Your multiplication factor is 1 plus or minus of, based upon whether it increases or decreases. Okay. Multiplication factor is 1 plus or minus of percentage equivalent fraction. So this becomes 1 since there is an increase, that means something is getting added. 1 plus, what is the equivalent fractional form? 1 out of 2. 1 plus 1 by 2, which is 3 by 2. I hope you got the basics here. A further simplification of this could be, whenever you see a percentage, first find out its equivalent fraction, keep the denominator as it is, and perform the required arithmetic operation. You see, there is an increase of 50%, that means on 2 units there is an increase of 1 unit, so the new unit will be 3. Now let us solidify this understanding with few examples. Some value A has decreased by 33.33%. Some value A has decreased by 33.33%. Now what is the multiplication factor? Your multiplication factor is simply 33.33%. First step is, it is 1 by 3, it has decreased, that means on a unit of 3 your multiplication factor is nothing but 1 plus or minus fractional form. It is decreasing, right? So 1 minus of 1 by 3, which is 2 by 3. Or you could directly, instead of doing this on pen and paper, you could do this in one step itself. Okay, so 1 minus, so one part is reducing out of 3 parts. So what are the parts that are remaining? 2 by 3. In the same way, something or a quantity A or a quantity B has increased by 75%, Find out the multiplication factor. A quantity B has increased by 75%. Same step. What is 75%? It is nothing but 3 by 4. What is the multiplication factor? It is 1 plus 3 by 4, which is 7 by 4. Or for people who are a bit logical, you could just derive this from here. 75% is 3 by 4. That means on a base of 4 units, there is an increase of 3 units. So the final value is 4 plus 3, 7 by 4. So the multiplication factor is 7 by 4. So what is the advantage of multiplication factor? Multiplication factor, since it contains the final value, within itself. At the first side itself, we have seen that our multiplication factor is nothing but final by initial value. So just multiplying any given value, any given initial value with multiplication factor directly leads you to your answer. Okay. It skips many 2 or 3 steps of initial 100 approach, where you need to find out how much it has increased. Okay. If you use initial as 100 approach, you need to find out how much has it is increased. Suppose it has increased by x, and you need to add 100. Okay, that to 100. So the new value will be 100 plus x. Your multiplication factor, although this might not seem to be that advantageous now, but when you see complex problems, multiplication factor is the way to go. So we have seen 1, percentage to fraction conversion, and 2, multiplication factor approach, and 3 will be divisions. Okay. It is related to this topic itself. You will not see these divisions in other. You might see them in different form, but for election based problems, there are a few types to be taken care of. What are those? First, just imagine our normal elections. What is the first thing? First thing is population. First thing is population or eligible voters. Or let me give you all the possible okay, first it is population. Just imagine the practical case of India itself. Okay. Out of this population, some are okay, few people are eligible to vote. Taking the example of India, if it is greater than, if someone is greater than 18 years, okay, people who are above 18 years of age become eligible to vote in elections. Now, after eligibility comes, okay, so in a population there is a division of eligible people, so there will be non-eligible people too. Okay, next, out of eligible people, just think of the same. If you have crossed 18 years of age, do you automatically get a right to vote, or do you automatically get a voter slip to vote? No, you need to get registered. So out of eligible people, there will be registered voters and non-registered voters. There will be registered voters and there will be non-registered voters. Next, in other words, we call this registered voters also as voters list. Next, what is the further division? Registered voters, some people vote on the election day, some people do not vote. So next division is people who vote. Next, people who do not vote. Out of the votes that are polled, what is the further division? Next, some votes will become invalid. Some votes will be invalid because of certain errors or all the external factors. Some votes become invalid, which means after you remove invalid votes, what will be remaining? It is nothing but valid votes. Okay, these valid votes are distributed among, suppose there are 5 candidates A, B, C, D and E. These valid votes are distributed among the candidates, and whoever gets a majority, since we are a first past the post system, okay, whoever gets a majority, okay, wins the election. Suppose out of the valid votes, suppose he got some 30%, he got 26%, he got, okay, so on and so forth. Whoever first past the post system, whoever gets the maximum number of votes, he becomes elected. So you need to have this sequence in mind. At the highest level, you will have population. Okay. So this is the sequence that an election based problem follows. Now, a few observations for you to solve election based problems easily. 1, in most of the election based problems, you will always be given, the problems will be on this format. There will be some information regarding percentages given. Suppose, for example, 10% of the eligible voters did not vote, or 25% of the votes became invalid. You will have some percentage information, and you will always have a value that is given. There will, in most of the cases, there will always be a value that is included. So the meta principle of all election based problems is you need to equate the information regarding this percentage. You need to equate the information regarding this percentage to this value given. This is all that is there regarding election based problems. Now, how do you do that? First step, since the destination is always based upon value, okay, so always think in think these percentage terms in terms of, or in those steps which take you closer to the value, I will explain this while we do a problem. Okay, it might seem a bit vague, but I am repeating this again. You will understand this much more clearly when we solve the problem. Okay, always convert your percentage values. The observation is convert your percentage values with the value in mind. And second observation that I want to give you is always start from, unless the problem appears too complex, always start from a higher level. What do I mean by that? Suppose if some information is given, always start with the higher level possible that is given in the information itself, because sometimes they will include population, sometimes they will include eligible voters, sometimes they will include voters list. Based upon whatever the maximum level that is given in the problem, start from there. Okay. Always your way of solving an election based problem should be downstream. You start from a higher point and then come down to the value whichever it is given. Okay. So these will be my observations. I am telling this again. Most of the election based problems will be some percentage values and equivalent value given. You should always think what is the easiest way or what is the simplest path that I can convert these percentages to value, that I can link these percentages to this value. Next, always start from a higher level. I hope this is sufficient. Now we will start solving problems one by one. We will start at a lower level so that you build enough confidence in yourself solving the problem, and after that we will see problems of a good complicated nature. Okay. So let us start with the first one. And please don't wait for my explanation. I'll write the question on the board or I'll dictate the question for you. Kindly pause the video, solve for yourself, make mistakes. You cannot learn without mistakes. Make your mistakes and then compare it to my this thing there. Okay. Then only after you solve the problem, unpause the video and see what is the solution. How is the solution dealt with? Okay. Answers are not important here. Your approach, the way of thinking is much more important than your answers. So, and you will only improve your thinking only when you make mistakes. So make a mistake and then compare with the answer. See the way I approach the problem. So let's start. In a poll, 1,20,000 votes were polled. 1,20,000 votes were polled. 10% of them were invalid. 10% were invalid. 10% were invalid. A candidate received, there is a candidate A, he received 60% of valid votes. 60% of valid votes. Find the number of votes polled by the candidate. He is asking how many votes does this candidate get. You see, The information given is here. The answer asked is, okay, number of votes of the valid candidate. Okay, so we need to reach from voters polled to votes of candidate. Okay. This is the highest level that is given in the problem. I am starting from here and I need to reach votes of the candidate. Okay, now start from here. These were the number of votes polled. Okay, so this is 1.2 lakh, or I'll just write 120k. Okay, 120k. Out of this, always have this mind, we need to find out the votes of the candidate. Always have the final destination in your mind. I need to reach votes of the candidate. Okay, does invalid votes contain the votes of the candidate? No, only valid votes contain the votes of the candidate. So if the 10% of votes were invalid, always do this conversion. I need to reach votes of the candidate, so I need to reach first what? I need to reach the number of valid votes. So if 10% are invalid votes, 90% will be valid votes. So what is the multiplication factor for 90%? 90% is nothing but 9 by 10. 120k into 9 by 10. Now I reach all the valid votes. You see, I started from a higher level of all the votes that were polled. The next subsequent level is number of valid votes, and next the subsequent level to this is the candidate A got 60% of the valid votes. 60% of the valid votes, same 60%. Can you write that as 20% into 3? 20% into 3. What is 20%? 20% is nothing but 1 by 5. We have seen in percentage to fraction conversion. So 60% is nothing but 3 by 5. So 120k into 3 by 5 are nothing but votes of the candidate A. Now so this is 12 into 9 into 3. Okay, k is 1000. 1000 by 5 is 200. Well, lines of 108 into 6, 48, 4, 6. Okay. So it is 6,48,000. Okay. So the votes of the candidate. So the final answer is the number of votes of the candidate are 6,48,000. You see how have we proceeded? The problem is not complex. You will see the same pattern. You have just seen one conversion here. How do somebody increase this complexity? Keep more conversions. Okay. So all election based problems are based on this format only. Okay. You keep those observations in mind. I need to reach from the information that is given to me to the question that is being asked. Okay. Many times the question being asked will be a value, sometimes it might be a percentage too. Okay. And you need to approach sequentially. Okay. So first we were given votes polled, but I need to reach the votes of the candidate. Which division contains the votes of the candidate? Because votes of the candidate come in valid votes, but I was given invalid votes. So convert. Okay. So convert invalid votes to valid votes. 10%. If 10% are invalid votes, valid votes will be 90%. So it is 9 by 10. Next, out of these valid votes, the next subsequent division is between the candidates. Out of the valid votes, 60% of the votes were given to A. So 60% is nothing but 3 by 5. Okay. I hope this is simple enough. No. Now I am increasing the complexity a bit. We will see the second one. In municipal elections, this is problem number 2. In municipal elections, there are a total of 4,000 voters. There are a total of 4,000 voters, and the subsequent information is as follows. 10% of the voters, 10% of the voters did not cast their vote. 10% did not cast their vote. 10% did not cast their vote. And 20% of the votes cast. Okay, 10% did not cast their vote. Out of the remaining votes that were casted, 20% were found invalid. 20% were found invalid. Candidate A won by a margin of 20%. Candidate A won by a margin of 20%. What do I mean by margin? Margin is nothing but A's percentage minus B's percentage. Okay, number of votes A got in percentage terms minus B's. Suppose if A got 50% of, if A got 75% of the votes, 75% of the valid votes, that means how many votes will B have? He will have that is 25%. So what is his margin? He won by a vote margin of 50%. Okay, this is just an explanation of margin. Okay. So in municipal elections, there were 4,000 voters. Out of this, 10% did not cast their vote, and out of the votes that were cast, 20 were invalid and candidate A. Okay, and this is municipal elections. There are only two candidates, A and B. There are only two candidates, A and B. Okay, candidate A won by a margin of 20%. Candidate A won by a margin of 20%. Okay, so the question is, how many voters voted for B? How many voters voted for B? How many voters voted for B? Pause the video, solve the problem, and then compare it with my explanation. Okay. We'll see the solution in few seconds. Okay, now let's solve. First, information and the destination. Okay, what is the destination? Votes of B. Votes of B. And what is the information given regarding B? A and B participated in it, and A's margin was 20%. Suppose 100% votes were there. 100% votes were there. 20% is the winning margin. 20% is the winning margin. Okay, that means A scored, or A got 20% votes more than B. So 100% is A plus B. A got 20% votes more than B. So can I write this as 20% plus B plus B? B is as it is. A got 20% more votes than B. So this becomes 20% plus 2B is equals to 100. Okay. 2B is 80% and B is 40%. Okay. So if B gets 40% of the vote, how many votes does A get? A gets 60% of the valid votes. I hope this is clear. So I have given a form to the destination that is being asked, which is I need to find out 40% of the valid votes. Because I need votes of B, I need to find out 40% of valid votes of B. 40% of valid votes of B. Okay. The destination is clear. Now start from the information given. What was the information given? We'll solve this here itself. Okay. B has 40% of the valid votes. I need to find out the votes now. Okay. So first division is always you should solve all election problems sequentially. Start from the top and reach the destination. Okay. So number of voters are 4,000. So I'll simply write this as 4K. Next, 10% did not cast the votes. Which division, just think of this, which division contains the votes of B? It is always, if these people did not cast, it is votes that are cast contain B. Okay. So 10% did not cast their votes. So how many votes were cast? Okay. 90% of the voters cast their vote. So 4K into, so number of votes that were cast, or the number of voters who voted is 4K into 9 by 10. Okay. I am simply using the multiplication factor way. Okay. Next, into 20% were invalid. 20% were invalid. What is 20%? 20% is nothing but 1 by 5. Okay. Out of 5 parts, 1 part is invalid. And now again ask the same question. Which division contains the votes for B? It is valid votes that are divided into A and B. So I need to find out the valid votes. Out of 5 votes, 1 vote was invalid. So the number of valid votes are 4. So the multiplication factor becomes 4 by 5. Now I have the valid votes. And how many of the valid votes did B get? He got 40% of the valid votes. 40% is nothing but 40% is 2 into 20%. 20% is 1 by 5. So this becomes 2 by 5. Okay. So we have reached valid votes here. These were total number of votes. These were votes that were cast. Out of the votes that were cast, these were the valid votes, and out of these valid votes, I get votes of B. It is 4 by 5 into 2 by 5. So this becomes 400 into 9 into 4 into 2. 5 5s are 25, right? 25. 16. So the answer is 16 into 9 into 8. Okay. Okay. So it is 16 into 72. Okay. So this is the final number of votes that I got. Okay. Normally in exam you have the options. This is a multiple of 16. Okay. You could directly see instead of doing this whole calculation itself, you could see which you could focus on the unit digit and see which stops with a 2. Okay. So it is 16 into 72, or you could easily calculate this is 72 into 10, 720 plus 72 into 6, 12, 42, 432. So the votes received by B were 1152. Okay. I hope this is clear. Next. Now let us see the next one. Problem number 3. The principle always remains the same. Think sequentially, have the final answer or have the final destination in mind and use multiplication factor approach. Okay. Now the next question is, in an election there were three candidates A, B and C. There were three candidates A, B and C. A got 50%. A got 50% more votes. A got 50% more votes than C. A got 50% more votes than C. Now I am introducing a new data set. Okay. A got 50% of more votes than B. B got 19 percentage points. 19 percentage points. B got 19 percentage points more than C. B got 19 percentage points more than C. If A got 72,000 votes, if A got 72,000 votes more than C, if A got 72,000 votes more than C, if A got 72,000 votes more than C, okay, find the total number of voters. Okay, and the final destination could be anything. Okay, he can ask for total number of votes, or he can ask for the votes of A, he can ask for the votes of B, he can ask for the votes of C. Okay, based upon the desire of the examiner, anything can be asked. Okay, once you solve the problem, everything becomes apparent. Okay, now pause the video and solve for the question and compare it with this. Okay, we will see the solution in a few seconds. A, B and C. A got 50% more votes than C, B got 19 percentage points more than C. If A got 72,000 votes more than C, if A got 72,000 votes more than C, find out the total number of voters. Find out the total number of voters. Now, in this problem, I am going to show you, okay, why I had to make a statement that the initial 100 value is not an efficient way to solve election based problems. I hope the question is still clear. ABC, A got 15. Okay, now I will show you how will you get stuck. Okay, suppose A, B and C. A got 50% of, sorry, rather than C, this is B, because I am already comparing with C in one this. Okay, it can't be 50% and 19% more points. Okay, A got 50% more votes than B. A got 50% more votes than B, and B got 19 percentage points more than C. Okay. So if you take, since the first statement is on B, if I take this as 100%, this has to be 150%. Now B got 19 percentage points more than C. So this is nothing but percentage points. In hard percentages itself, he has given us this. Okay, B, the percentage of B is equals to C percentage plus 19 percentage points. Since we have assumed the value of B as 100, okay, 100, or you could take 100 or 100x, okay, anything you wish. 150, 100. So C has to be what? C plus 19% is 100. So C has to be 81. Okay, C has to be 81. Now, what has he given? If A got 72,000 more votes, if A got 72,000 more votes than C, or take this as x, this is 100x, this is 81x, okay, this is 150x. Now, I am just showing you the perils of blindly following the initial value as 100. So 150x minus 81x is equals to 72k. Okay. We need the total value here. Okay. Find the total number of voters. Total number of voters are 150 plus 100, 250, 250 plus 81, 31 more than 200 we need. So this becomes 231 by 69 into 72k. The calculation there becomes difficult. Okay. Now we will solve the same by using our ratio or multiplication factor approach. You see how easy it becomes to solve this. So I am just erasing this. Getting to the answer is not the most important thing. Be as efficient as you can. Okay. A, B and C. Okay. A, B and C. Instead of taking the value as 100, I know that A is 50% more than B. A is 50% more than B. What is the equivalent for 50%? It is 1 by 2. That means if there were 2 units for B, A will have 2 plus 1. 50% more is 1 unit more. So 2 plus 1 will be 3. So if B is 2x, A will be 3x. If B is 2x, A will be 3x. Next, B is 19% more than C. So C becomes 2x minus 19. Okay. C becomes 2x minus 19. Now what has he given? A got 72,000 more votes than C. A got 72,000 more votes than C. So what will this be? 3x minus 2x plus is equals to 72k. Okay. So I have, okay, 2x minus this, since, okay, 2x minus 19%. This is A, this is C. So the equivalent value will be 3x minus 2x will be x. Okay, minus and minus plus. So x plus 19%. Okay, x plus 19% is 72k. Now can we do something about this? Okay. So this total is equals to 100% votes, right? Here the final is at a value and here it is in percentages. Just convert this percentages to value. So what will this be? This whole is 100%. That means 3x plus 2x plus 2x plus, sorry, plus 2x minus 19 plus 2x minus 19% is 100%. Okay. So this becomes 3 plus 2, 5. Seven x minus 19 is 100%. So 7x will become 100 plus 19. X is equals to 119 by 7. So 7 ones 49, 7. So x is equals to 17%. Okay. Now x is 17%. 17 plus 9, 36%. Okay. 36% of the total voters is 72k. 36% of the total voters is 72k. That means what is full percentage? 36% is 72k. Okay. So 100% will be 200k. Okay. So these are total number of voters. Total number of voters are 200,000. Okay. You see how easy the problem is. Okay. Instead of going into the calculation, because the problems are designed that way. Okay. Do you think UPSC or the examiner has given you a random value of 72,000 votes as it is? No. He wants you to solve the problem in the most easiest way possible. Okay. So the answer for this is 200,000. You see, all this complexity goes if you assume the correct way or if you do the problem in the correct way. Okay. So based on tricks, see, instead of taking 100 as it is, we are taking a measured approach. Percentage to fraction, and based upon fraction 2x, 3x, 2x minus 19. So 2x minus 19 is 17k. Okay, so x plus 19 is 72k. So this is in terms of percentages and this is in terms of value. So I need to find, okay, an equation which converts my percentage to value. Okay, we all know this is 100%, right? So 3x plus 2x plus 2x minus 19 is 100%. So x becomes 17%. Okay, so 36% is 72k. Since he has asked for total number of votes, 36% is 72k, 100% is 72k by 36 into 100. So this will be, okay, 20,000 votes. And you can solve any one of the problem now. Okay, if he asks for, suppose the votes polled by A, it is nothing but 3 into 17, 17 threes are 51%. So 51% of 20,000, it is nothing but 10,200. In the same way, you can find this, 17 is 34%. Okay, this is 34 minus 19. Okay, so this is, okay, 15%. This is 85%. This is 15%. Okay, you can solve any of the format they have asked. Okay, if you do it the right way. So if you would have observed, we followed only one principle. Okay, what is that principle? One. Or we have followed all our observations throughout all the problems that we have seen. Okay. One, always have the final destination in mind. Final destination in mind. Convert every percentage value information given to the final one. Next, always start from a higher level and reach the asked level Okay, if they give me margin, I'll think in terms of margin. If they give me B, votes of B, I'll think in terms of votes of B. If they ask me in votes of A, I'll think in terms of votes of A. Okay, along with percentage to fraction conversion, and multiplication factor. Okay, these 3 or 4 steps, okay, is what is needed to solve any election based problems. Okay, the complexity increases by just increasing the number of steps. Instead of giving voters, sometimes they will give you registered voters. Instead of giving registered voters, sometimes they will give you population. Okay, so this is all the complexity there is to election based problems. Follow the observations, you will definitely solve any election based problems if you stick to the process. Okay, now same time next Saturday we are going to solve one more niche problems, okay, which are matrix based problems in percentages only. Matrix based problems. We see these problems frequenting in CSAT 2. Okay, so what are matrix based problems? A simple example I give you is, in a school there are boys and girls. For example, 60% are boys, 40% are girls. They'll give information like this. 20% of the boys wear a fragrance, and 60% of the girls do not wear a fragrance. You see, first a total unit is divided into boys and girls, and next boys and girls are divided into who wear fragrance or who do not wear a fragrance. It might be some divisions like that. You see, it is First, 1 is divided into 2 and this 2 is divided into further 2. Okay. So, the easiest way to solve such problems is by forming a matrix, a visual representation of this information in form of a matrix is the easiest way to solve all such problems. So, in the next session, I hope all of you will attend. Okay, we will see all, like how have we generalized for election based problems. I will give you a recipe for solving all matrix based problems. Okay, you keep my observations in mind, and any of matrix based problems can be solved like that. I hope you have learned something new today, and I have enjoyed teaching you this, and you have done the same while solving the problems. Okay, and one suggestion I give you is, now to solidify this, the thing that we have learned now, okay, just go back, see all the CSAT problems which are on this kind. Okay, see all the problems, CSAT problems which are election kind, on which are based on election. Solve those. I am definitely sure you are, with these principles in mind, you will definitely solve all those. Okay, so we'll meet in the next session at the same time with matrix based problem. I will give you a generalization for that. Just keep it in mind and apply the same in all matrix based problems. You will definitely solve those. I hope you have an so next week at the same time we'll be back with an open session on matrix based problems. Have a good day. Thank you.